Hello there, 8th grade. Welcome to lesson 812 for the week. We're going to kind of continue our discussion on simple versus compound interest briefly, and then I'm going to introduce you to some exponent rules that are going to be absolutely critical for you in the future. So I want to just talk about this first problem where they're discussing the difference between simple interest and compound interest. And the idea is if you calculate based on simple interest, you are taking an initial amount. In this case, the initial amount is $10,000. And they are then applying a percentage to it every single year. So in this case, she has a 5% simple or 5% compound. So what you'll notice is that when you are dealing with simple interest, the amount that it's increasing by is a fixed value. It says it goes up by exactly $2,500 each 5 years. And in compound interest, the values are a little bit different. But I want you to look at the 30-year amount for each of these. In each of these cases, the 30-year value is way better for compound interest. It's the same 5%, but she's going to be making a little bit under $20,000 more in the 30-year value. So the idea is that compound interest is going to grow by more and more each time you do it. And we're going to look at some of these examples. Specifically, this idea is somebody started with $500. That's their initial principal value. It's what's listed right there on the table. And then it says the account pays 5% compound interest every year. Now, this 5% compound interest translating to 1.05 in this image is a little bit not clear. So I want to share with you the method that I prefer to use when you're dealing with interest. You've got a value that is 5% interest that is a gain of 5%. So in other words, you are adding 5% interest every year. Pretty simple. But everything in your account starts off with 100% of its value. So if you had 100% of your money, which you do at the start of the year, and you are adding 5% to that, this strategy is going to let you come up with the value you multiply by each time. I understand I'm kind of jumping the gun on this, but I want to show where this 1.05 came from. 100% plus 5% is 105%, which means that each year you have 105% of the money from the year before that. And you change this to a multiplier by moving the decimal so it becomes 1.05, which is where they got this value from. The idea is that each time they do this, they multiply by times 1.05. To find the next year, times 1.05, and so on and so forth. And what's going to happen is that those are going to go up and up each year. And what I'd like you to see is that as you do this, you're going to get a curved graph that's going to go up like this. Okay, it's going to be an exponential growth equation. Now, the other thing to talk about is that each time they are multiplying by a 1.05, what that looks like is that it's becoming more and more copies of 1.05. So you don't necessarily want to write out each of these 1.05s every time you do this. So we're going to shortcut this using exponents. So 1.05 times 1.05 is the same as 1.05 squared. Pretty easy. 3 of them is 1.05 to the third. One of them is 1.05 to the 1. 3, and 3, 2 and 2, 1 and 1. How many 1.05s are here then? The answer is 0. But the interesting thing is that this sort of leads to an equation without really showing you where it comes from. I start with $500 and I'm multiplying by 1.05 a number of times, which is this x in the exponent. So if you want to find the balance at 18 years, which is, a little bit far out, you don't want to create a table that goes from 4 all the way down to 18. That's going to take you forever. So you use the fact that it's 18 years and that each time we wrote years on this problem, okay, 3 years, 3 exponent, 1 year, 1 exponent. We'll deal with 0 years, 0 exponent later. That's a weird case that we'll talk about. If I want to know 18 years from now, take 500, 1.05 to the 18th power. In your calculator, there's a button on the left side that looks like a little up arrow. So you can put in 1.05 up arrow to the 18th. And it's going to let you put in 18 as the exponent. Okay. So this shorthand for exponents is you take a number that is repeated multiplication, such as 4 times 4 times 4 times 4 times 4, and you write it as 4 to the power of 5. This is the best time to realize that this is not 15. 5 to the third is 5 times 5 times 5. 5 and 5 is 25, times 5 is 125. So I want you to try 8-17. If you don't get the interest stuff with this equation, don't worry about it. This is very new and you are not expected to master that until way later in your freshman year. 8-18 is a simple interest problem, so use the formula we talked about. 8-19 is standard form where you're writing powers of 10. All you're doing is you can do these to the 7th power would have how many zeros? 10 to the third has how many zeros, and so on. 8-20 is when you're dealing with discounts. If you have an 8% discount, there's 2 ways to solve this. You can either do 0.08 times the price, or you can do 0.92, which is the 92%, because that's what's left. And then you can figure out the amount that he paid with this discount. So for the discount price, you do 0.08 times the price, which is $42.98. And if you want to know the amount that he pays, you take this amount minus the value you got there. Okay. For 8-21, to determine if it is a proportional relationship, it has to go through 0, 0. And I want you to think about this. If it costs you a rental price for the bus on this problem, $350, then it does not go through 0, 0 because it costs you to rent the bus even if you bring 0 students. So I'm going to leave that there for you. This one is to simplify. Remember your fraction rules. And then if you need help on that, come by in office hours. And when you graph it, dilate is to just enlarge or reduce. In this case, it's enlarging. Multiply every number in this problem by 2, and that will give you your new shape. So try graphing it on the points with the points given, multiply everything, and then start listing out your new points. So for example, this one you've got 0 and 1. If I multiply that by 2, I end up with 0 and 2. Multiply this by 2 and I get 6 and 4, and then do the same thing for the last one to get your new points. So that's all I've got for you this week. Next week expect us to dive more into exponents. You will be so sick of exponents by the end of this class, but it is very valuable practice. So good luck 8th grade.